Hello viewers, this is a quick review of a practice test for foundation mathematics. The first problem says given that x star y is defined by 2x minus y, where x and y are real numbers, examine whether star is binary on the set of real numbers. Then solve the equation. Now, first of all, you would want to identify that this question is coming from binary operations. Now, a statement is said to be binary on a set if that statement yields elements that belong to that set. So number one, the question is star binary. Okay, so we would want to take any numbers, right? So take any numbers, say x and y, which are in the set of real numbers. Okay, so you can see that x star y is just the same as what? 2 multiplied by x minus y. Now, x is a real number, multiplied by 2 is still a real number. When you subtract any number y, it will still be a real number. So x star y is a real number. Okay, I can take a quick example, say 1 star 2, which is equal to 2 on 1 minus 2, which is equal to 0, and 0 is a real number. So therefore, we conclude that star is binary on the set of real numbers. Now, a bonus question I would ask to say, maybe let's take this one as 1, and let's take a second one. So I can ask to say, is star commutative on R? Now, by commutativity, we mean if you take any for all x and y in R, we want x star y to be equal to y star x. The question is, does that hold? Okay, now we know that x star y is equal to 2x minus y. That is twice the first number minus the second number. Now, y star x is equal to twice the first number, which is y, minus x. You can see that these two are not the same. 2x minus y is not the same as 2y minus x. For example, we said in A, from 1 we said 1 star 2 is equal to 0. Now, what is 2 star 1? 2 star 1 means twice, that is in the definition twice, y is 2, then minus x, which is 1. And this is just what? 4 minus 1, which is 3. And we know that 0 is not equal to 3. Therefore, star defined by x star y, which is equal to 2x minus y, is not commutative on the set of real numbers. Now we want to solve this equation. Given the definition of star. So to find the value of t, we are going to apply the definition of star. So first I start with what is in the parentheses. So I keep what is outside, which is 3t star. Now what is inside, I have t star negative 1. The definition of star says twice the first number, which is t, then minus the second number, which is negative 1. This is equal to 5. So I can expand this. This is just 3t star 2t plus 1, which is equal to 5. Okay. Now my x becomes 3t and my y is 2t plus 1. So star applied on this I have twice. The first number is 3t, then minus the whole expression 2t plus 1. This is equal to 5. Okay. Now I expand here. This is 16 minus 2t minus 1 is equal to 5. Now this is just 4t is equal to, this is 5 plus 1, which is equal to 6. So therefore, t is equal to 6 divided by 4, which is just 3 over 2. So question 1 is done. Now question 2 says, show that the square root of 3 plus 1 is irrational if the square root of 3 is not a rational number. So in constructing your proof, you would want to say that we want to show that the square root of 3 plus 1 is irrational. So you will say by contradiction. Okay. Now, to prove by contradiction, you are going to assume or suppose that this guy root 3 plus 1 is rational. Okay. What it means when this number is rational, it means that you can find, that is, there exist some numbers a and b with b not equal to 0, such that the square root of 3 plus 1 is equal to a over b. Okay, where a over b is reduced, right? A over b is a simplified fractions. Now we can reduce throughout by 1. So this is 3 is equal to, this is 3 is equal to a over b minus 1, which is just a minus b over b. Okay, but you know that b is not equal to 0, and a minus b is just some integer, right? So a over b is, I mean, a minus b over b is a simplified form, which is irrational. Okay, so this is contradiction, right? But root 3 is not rational. Okay, so root 3 equal to a minus b over b is not possible. Okay, is not possible. Then you conclude thus, or therefore, or hence, square root of 3 plus 1 is indeed irrational. Then you are done. You have your 5 marks. The next problem involves absolute value equations. So the first one we want to solve for x when the absolute value of 2x plus 1 is equal to 3x minus 1, the absolute value of 3x minus 1. But note here that the absolute value of x is equal to a implies x is either positive a or negative a. So we are going to apply that. So this is just 2x plus 1 is equal to plus or minus 3x minus 1. What this means is that 2x plus 1 is equal to 3x minus 1, or 2x plus 1 is equal to negative 3x minus 1. So let us start with the first one. This is just what? I can subtract 3 both sides so that we have 2x minus 3x is equal to subtract 1 both sides, so you have negative 1 minus 1. So this is negative x is equal to negative 2. Divide throughout by negative 1, x is equal to 2. On the right side, you have 2x plus 1 is equal to negative 3x plus 1. I add 3 both sides. I have 5x is equal to reduce 1 both sides, we have 0. So that upon dividing throughout by 5x is equal to 0. Okay? So this equation is true only when x is either 2 or 0. So part B, hence or otherwise, we want to sketch the graph of f of x is equal to the absolute value of 2x plus 1 minus the absolute value of x minus 1. Okay? Now, you would want to observe one thing. First of all, we can determine the intercepts, right? So let us take the x-intercepts. So x-intercepts, you know that f of x is equal to 0. So the whole function is 0 when you are on the x-intercept. So you are just saying that the absolute value of 2x plus 1 minus the absolute value of 3x, minus 1 is equal to 0. So that you have 2x plus 1 is equal to the absolute value of 3x minus 1. So you can see here that this statement that I wrote here is not necessarily important, right? Because on the x-intercept, f of x is 0, and when x is 0, when f of x is 0, the problem reduces to the first part of the question where x is either 0 or 2. Okay, so this function has the x-intercept at 0 and 2. Okay, now you can get the y-intercept. Let's say y-intercept. Y-intercept, you know that x is equal to 0. So what is f of 0? This is just the absolute value of what? 2 on 0 plus 1 minus 3 on 0 minus 1. But this is just the same as the absolute value of 1 minus the absolute value of negative 1, which is just 1 minus 1, which is 0. So it will pass at 0, 0. Okay? So you have the x-intercept and the y-intercept. Okay. So I am making sure that I add all the details that you need to draw to sketch a most accurate graph. Now, what is more important now, other than the x and y intercepts, that is, if they exist in this case, right? You can observe that this is a sum of two functions. So we are going to get the critical values. Now, critical values are points that makes each part 0. So 2x plus 1 is equal to 0. This can only be true if 2x plus 1 is equal to 0, which implies that x here is equal to what? Negative 1 over 2. Okay? And the second part is 3x minus 1 is equal to 0. This is true if 3x minus 1 is equal to 0, so that x is equal to 1 over 3. Okay? Now, the next thing is to redefine this function. We want to write our function as a piecewise function. So this piecewise function is going to have three regions because we have three critical points. So I will draw a very simple table. I have negative 1 over 2 and I have 1 over 3. So on the right side, I have all the values of x that are greater than or equal to 1 over 3. And here I have values that are between negative half, less than or equal to x, and this is less than 1 over 3. And here I have values of x that are less than negative half. Okay. Let us start with the right part. On the right part, we are saying that the values of x are greater than 1/3. Now, remember the input of this function, each of these function can either be positive or negative. This one can either be positive or negative. Okay? Now, if you redefine each of these functions, say the first one, 2x plus 1, it will be positive if the values of x are greater than or equal to negative half, and negative if the values of x are less than negative half. And so is 3x minus 1 positive for x greater than or equal to 1/3, and negative for values of x that are less than 1/3. So for values that are greater than 1 over 3, those values are also greater than negative half. So the first one will be positive, so that is 2x. Let me use a different color. That is 2x plus 1 minus, the other one is also positive, so that is 3x minus 1. This becomes 2x plus 1 minus 3x plus 1. So this is 2x minus 3x, which is negative x, then plus 2. Okay? In the middle, the values of x here are greater than negative half. So I pick the positive part, 2x plus 1 minus, but the values of x are less than 1 over 3. So meaning that I will pick the negative part of that guy. So minus negative is positive. Okay, so minus, and the sign from 3x minus 1, it becomes positive. So this is 3x minus 1. Now that is 2x plus 3x, which is 5x. 1 minus 1 is 0. So this is just the line y is equal to 5x. On the left, the values of x are less than negative half. So I would just say negative 2x minus plus 1 minus, the values of x here are also less than 1 over 3. So to be minus and another minus to be positive. So this is 3x minus 1. So negative 2x minus 1 plus 3x minus 1. And this is just x minus 2. That is negative 2x plus 3x, which is x minus 2. Now we can sketch our graph. I start with the intercepts. I have 0, 0, and we also had 2, right? We also had 2, 0. Okay. Now let us start with the middle part. The line y is equal to 5x. Okay. Y is equal to 5x. We know that it is between negative half and 1/3. So let's say this is my negative. Let's say this is my negative half. Let's say this is 1/3. Okay. So I know that I will have some point here and some point here. Okay. So let's say when x is 1/3, so this will be y is equal to 5x, where x is 1/3, so that is 5/3. So this will be some point 5/3, and at the bottom this will be some point negative 5/2. Okay, so I just connect this. Okay, now on the right part, this is the x-intercept, so I just connect like that. Okay, and on the left part, this will just go like that. Okay, so why is it going like this? Say I pick negative 1 here. This is y is equal to x minus 2, so that y is equal to negative 1 minus 2, which is equal to negative 3. So this is negative 1 comma some negative 3. This is negative 2.5, so negative 3 will be close here, okay, which is somewhere there. Okay, so this graph is moving from negative infinity to positive infinity, and that's it. Next, we want to sketch the graph of f of x is equal to x plus 3 over x squared minus 5x plus 6. So the first thing, I will locate the vertical asymptotes. So you know that on the vertical asymptotes, the denominator is equal to 0. So x squared minus 5x plus 6 is equal to 0. I can factorize this as x minus 2, x minus 3 is equal to 0, right? Because negative 2 minus 3 is negative 5, and negative 2 multiplied by negative 3 is positive 6. So therefore, the vertical asymptotes are x is equal to 2 and x is equal to 3. Okay. Now for the horizontal asymptote, you can see that the degree of the polynomial in the numerator is less than the degree of the polynomial in the denominator. So the horizontal asymptote is just a line y is equal to 0. Let us find the intercepts. I start with the x-intercept. On the x-intercept, y is equal to 0. So that is the whole function is 0. So x plus 3 over x squared minus 5x plus 6 is equal to 0. This can only be true if x plus 3 is equal to 0, so that x is equal to negative 3. Okay, so I have my x-intercept as negative 3, comma 0. Next, I find the y-intercept, if there is any. Okay, now on the y-intercept, I know that x is equal to 0. So I compute f of 0, which is equal to what? That is 3 over 6, right? Everything, all these guys are 0. So I have 1 over 2. Okay, so the y-intercept is the point 0, comma 1 over 2. Okay, so I have my asymptotes and my intercepts. The next thing is to sketch the graph. So that is my graph. Okay, I put my x-intercept, negative 3. Then let me put the asymptotes. This is the line x is equal to 2. And this is the line x is equal to 3. Okay, I also have the y-intercept, which is some point half here. Okay, so my graph goes like that. Okay, it goes like that. Okay, so it comes from the vertical asymptotes, crosses at 3, then follows the horizontal line. For the values of x that are greater than 3, okay, so when x is greater than 3, it's a positive number, right? So this thing is positive here. Okay, now if I pick any number that is between 2 and 3, the function is negative. So this graph goes like that. Then this is done. The next problem says simplify or express the square root of 2 plus 1 over the square root of 2 minus 1 plus the square root of 2 minus 1 in the form of alpha plus beta multiplied by the square root of 2, where alpha and beta are real numbers. Okay, so what I would do, I would first of all rationalize the first part. Okay, so let's take that which I've circled in red. I have the square root of 2 plus 1 over the square root of 2 minus 1. So I multiply by the rational conjugate of the denominator, that is the square root of 2 plus 1 over the square root of 2 plus 1. Now in the numerator, I have a product of one same thing, which is a perfect square. So this is just uh, I just square the first term, which is just 2 plus twice the square root of 2 plus 1 over, that is a difference of 2 squares, just 2 square root of 2 squares, square root of 2 squared minus 1 squared. Now this is just what? This is just 3 plus twice the square root of what? 2 over 2 minus 1, which is just the 1, right? So this simplifies to 3 plus 2 the square root of 2. Okay, now remember, this is just for what I circled here in red. So therefore, the whole expression becomes 3 plus 2, the square root of 2, plus the remaining one is the square root of 2 minus 1. Okay, so this is what? That is 3 minus 1 is 2, plus the 2, the square root of 2, plus the square root of 2 is 3, the square root of 2. Okay, So what I did, I just expanded here, right? This multiplied by that gave me that, and this multiplied by that. But I just used what I know. So let me just give you a hint. In the numerator, I used a b squared is just same as a squared plus 2ab plus b squared, right? So I square the first term, which will just give me 2, then twice ab, then b squared, which is just 1. Then in the denominator, I use the difference of two squares. So that is a minus b, a plus b, which is a squared minus b squared. Okay. The next problem, we want the domain of this function log of x squared plus 7x plus 12 in base 5. So what you need to understand is the input of a logarithmic function is always greater than 0. Okay, it is always greater than 0. So the task is just to solve the inequality when whatever is here greater than 0. So the domain, it is just solving x squared plus 7x plus 12 greater than 0. Now we are going to factorize the left side, that is x. The sum is 7x and the product is 12, so I have 3 and 4 as factors. So I have plus 3 and and plus 4, which is greater than 12. Now here I will not say x is greater than negative 3 and x is greater than and x is greater than negative 4. Please do not do this. Okay, so what we will do, we are going to find critical values, that is values that make each of these factors 0. So the first one is x plus 3 is equal to 0 if and only if x is negative 3, and x plus 4 is 0 if and only if x is what? Negative 4. Okay, so after finding the critical values, we're going to do the sign test. So I put my negative 4 here and I put my negative 3 here. So this is a number line. Now if I pick a number, say that is less than negative 4, which is negative 5, I have negative 5 plus 3, right? X is negative 5 plus 3 is a negative number. Then multiply by negative 5 plus 4 is also a negative number. So the sign of any solution for all the values of x that are less than negative 4, we're going to have positive, and the positive number is greater than 0. So this is part of a solution. Similarly, if I pick a value that is greater than negative 3, say I pick a value 0 here, I have 0 plus 3 and 0 plus 4, which is some positive number. So a positive number is greater than 0. So that is plus, okay? However, if I pick a number that is between negative 4 and negative 3, say I pick negative 3.5, you can see negative 3.5 is negative on the first one, but it will give a positive number on On the second one, that is negative 3.5 plus 4 is positive. So this is negative. Okay, so a negative number cannot be greater than 0. So this is not part of the solution. Okay, so therefore, as an interval notation, the solution is from negative infinity to negative 4, then union negative 3 to positive infinity. And this is done. Question 7 says alpha and beta are roots of a quadratic equation that is 2x squared plus 5x plus 2 is equal to 0. Now we want to find the sum and an equation that connects alpha squared and beta squared. Now one thing you need to remember is that if alpha and beta are roots of an expression, then you can factorize an expression as x minus alpha multiplied by x minus beta, which is equal to 0. And when you expand this, you find that x minus alpha plus beta, x plus alpha beta is equal to 0. Okay, so this is the basic thing that you need to know. And from this, we infer that alpha plus beta is equal to negative b over n. And we know that alpha beta is equal to c over n. So from the given equation, we can find alpha plus beta. So this implies alpha plus beta is equal to negative. B is 5 and A is 2. And alpha beta is equal to C is 2, A is 2. So this is just 1. Okay. Now we can go ahead and solve the first part. So the first part, we are looking for this sum. So the sum is 1 over alpha squared plus 1 over beta squared. Now, if you are given a sum, the ideal thing is to express it as a single fraction. So the common denominator is alpha squared, beta squared. Okay, now alpha squared into that, you remain with beta squared here, plus alpha squared. I can rewrite this as alpha squared plus beta squared over alpha beta squared. Okay. But we do not know what alpha squared plus beta squared is. So I will note here that alpha plus beta using this perfect square, that alpha plus beta squared is equal to, this is just alpha squared plus twice alpha beta plus beta squared. Okay, so this implies I make alpha squared plus beta squared subject. So this is alpha squared plus beta squared is equal to, I bring twice alpha beta on the left side so that I have alpha plus beta squared minus 2 alpha beta. Okay, so my so this sum becomes, right, this sum 1 over alpha squared plus 1 over beta squared is equal to, it becomes what? Whether it is alpha squared plus beta squared, I put that sum here. So I have 1 plus, alpha plus beta squared minus twice alpha beta over what? Alpha beta squared. Okay. So what did I do? First of all, I expressed this expression as a single expression, the sum as a single expression, but in the numerator I have alpha squared plus beta squared. So I find an expression for alpha squared plus beta squared because I only know alpha plus beta and alpha beta. So my expression only needs to have alpha plus beta and alpha beta. Okay. In the numerator, where there is alpha beta, I put negative 5 over 2 squared minus twice. What is alpha beta? Alpha beta is 1. Everything over alpha beta is 1 squared. Okay. So that is 25 over 4 minus what? Minus 2. So I just express this as a single fraction. Okay, which is just 25 minus 8 over 4, which is just 17 over 4. Okay, so this sum is 17 over 4. Okay, next we want to determine, we want an equation with roots alpha squared plus beta squared. So from the preamble here, we noted something here, the equation that connects these roots, that if alpha squared and beta squared are roots, then we have that x, okay, I can just write, we have that x minus alpha squared, x minus beta squared is equal to 0. You don't necessarily need to write this, okay? But upon expanding, like what we did in the first part, we are going to have x squared, you're going to have x squared minus the sum of these roots, which is alpha squared plus beta squared, x plus the product of the roots, which is alpha squared beta squared, is equal to 0. Okay, now what is this? This is alpha squared minus, I'll just write here, alpha squared plus beta squared x plus alpha beta squared is equal to 0. Okay, so the equation with roots alpha squared and beta squared is going to be given by that. Okay, but from A we have that alpha squared plus beta squared is just the same as what? That is alpha plus beta squared minus 2 alpha beta, which you do not necessarily have to calculate because we have already computed it here, right? But I may just compute it again just for fun. Okay, so this is negative 5 over 2 squared minus 2 multiplied by 1, and this gave us 17 over 4. Okay, and on the other hand, alpha beta is equal to 1, so the square is just what? Just 1. So this gives us what? X squared minus 17 over 4x plus 1 is equal to 0, which is just 4x squared minus 17x plus 4 is equal to 0. So I just multiplied that by 4. and this is done. Question 8 says, given that f of x is equal to x power 3 plus dx squared plus 3x plus 6, and f of negative 1 is equal to 2. So find the remainder when f is divided by 3x plus 2. So this question typically uses the remainder theorem. Okay, you can use synthetic division, long division, but those other methods are a bit longer. Okay, but by the remainder theorem, you can start with the first one. We know that, mind you, we have to look for d first of all, then find the remainder. Okay, because we don't want our remainder to be in terms of d. Why? Because we have been given f of negative 1, which is 2. Okay, now what is f of negative 1? F of negative 1 is equal to, where there is x in the function, I put negative 1. This is negative 1 power 3 plus d for negative 1 squared plus 3 negative 1 plus 6. Okay, now I know that this expression is equal to 2, right? So I have negative 1, that is plus d, minus 3 plus 6 is equal to 2. And if you solve this, you have d to be equal to 0. Okay, so I find d as 0. So my function is f of x. So our function is f of x is equal to x power 3 plus 3x plus 6. Why? Because d is 0. Now the remainder theorem says if we divide f of x by x minus c, then the remainder r of x is just the same as what? F evaluated at c. Okay, so the question is, what is the remainder when we divide our function by 3x plus 2? Okay, so I just solve for x in this divisor. So that is 3x plus 2 is equal to 0, which implies 3x is equal to negative 2. So that x is equal to negative 2 over 3. Okay, so my x negative 2 over 3 is my c. So therefore the remainder r of x, just the remainder, right? You can say r of x, we can just say the remainder is given by f of negative 2 over 3. Okay, so I substitute, this is negative 2 over 3 to the power 3 plus 3 negative 2 over 3, then plus 6. Okay, and this is negative 8 over 27, and this is minus 2 plus 6, which is negative 8 over 27 plus 4. Okay, so I express this as a single fraction, 27 over 27. This is negative 8 plus 108 over 27. Okay, then we're done, right? This is just 100 over 27. Okay, so the remainder upon dividing the given expression, which is x power 3 dx squared plus 3x, when f of negative 1 is 2, by 3x plus 2 is 100 over 27. So what did I do? I just used the given info to find the value of D, substitute, then apply the remainder theorem. Then we are done, right? Now I leave question 9 and 10 as your task. You can send in the comment section and see what you get. Send in the comment section, see what you get on question 9 and 10. If you have a different method of solving any of the questions from question 1 to 8, please feel free to hit in the comment section and propose a method that could help someone, and make sure you share this video to your friends, to your colleagues, to your students, and to your colleagues, and all the best.